Hi, my name is Jennifer, and in this video, I'm going to show you how to simplify rational expressions. So grab a pencil and some paper and work through these examples with me. Take a look at our first example. We have 3x squared minus 9x over 12x squared. The question is to simplify this rational expression. Simplify means to make smaller. So here's how we're going to solve this problem. Before, we are going to cancel like terms if we see something on the top that's like the bottom. However, we cannot break apart a polynomial. For example, even though we see a 3x squared and a 12x squared on the bottom, we cannot cross these out, not yet, because the 3x squared is part of a binomial. Okay? Because of this subtraction sign, they're kind of, they go together. They're attached together. And so before we can solve this problem, we need to factor the polynomial, and then we can cross out like terms. So here's how we're going to continue this problem. We're going to take the numerator and we're going to factor by pulling out a 3x. We'll draw our set of parentheses. If we were to factor 3x squared, or factor 3x out of 3x squared, we'd be left with an x. And then a negative 9x, we factor out of 3x, we're left with a 3. The 12x squared can still stay on the bottom. Okay, now we're ready to cancel. We have 3x on top as a monomial. It can cancel with the monomial on the bottom. The x minus 3 is a binomial. It can only cancel with another x minus 3 in the denominator. There is not another x minus 3 in the denominator, so it has to stay. But we can look at 3x and 12x squared. The 3 and the 12, if we divide both of those numbers by 3, we're left with a 1 and a 4. Next, if we cancel out the x and the x squared, we're left with nothing here, and we're left with 1x on the bottom. The hardest part about simplifying these is just making sure you're clear with what numbers you have left over. On top we have a 1 and we have x minus 3. Because 1 is going to be the coefficient, we don't have to write that, so we can just write x minus 3. And it's okay that we drop the parentheses off. On the bottom, we are left with this 4 and an x. And so we're going to put the 4x on the bottom. And this will be our final answer. Even though we do have an x on top and we do have an x on bottom, this x is connected to the minus 3. That makes the binomial. So it cannot cancel with this x. That's a monomial. So this is our final answer. X minus 3 over 4x. Okay, let's try another example. Let's simplify the rational expression 7x minus x squared over x minus 7 quantity squared. Now, like I said in the previous example, we cannot start canceling x terms or the 7s because they're already inside of a binomial. But let's go ahead and factor by breaking them back into a multiplication problem and see what we can work with. Let's look at this top expression, 7x minus x squared. Notice that, first of all, it's not in descending order. If it were in descending order, we would have a leading coefficient of a negative number because the negative x squared would come first. So I'm going to go ahead and factor that negative number out, and I'm going to factor an x out because they both share an x. And here we go. If I factor out a negative x, and I'm going to put this problem in descending order at the same time, so watch carefully. If I start with this term first, because it has the highest degree, if I factor a negative x from a negative x squared, I'm left with a positive x. Now I'm going to go to this term. If I factor a negative x from 7x, I'm left with a negative 7. Now let's take a look at the bottom. The bottom is x minus 7 quantity squared. What that means is that we've multiplied x minus 7 2 times. Now that we've completely factored, we're ready to simplify. An x term, this is a monomial, it can only cancel if there's another x monomial on the bottom, and there's not. This is a binomial, x minus 7. It can cancel with another x minus 7. There's 2 x minus 7s on the bottom, but it can only cancel 1 time. So we can cross those out. Now let me remind you, even though there's an x here on the bottom and an x on the top, this x is part of a binomial, so it can only cancel if there was another binomial on top. So our final answer is negative x over x minus 7. Okay, let's solve one more problem. Take the rational expression x squared plus x minus 12 over x squared minus 6x plus 9. Okay, before we simplify this, we're going to factor both of these trinomials first. Because let me remind you, even though there's an x squared in the numerator and an x squared in the denominator, we cannot cancel these two unless it's a perfect image of this trinomial. This x squared is connected with the positive x and the negative 12. It's different from what this x squared has. It's connected with the negative 6x and positive 9. So we cannot cancel these two. So our option is we're going to have to factor. I'm going to draw 2 sets of parentheses. Take a look at this top trinomial. We'll put our x's in place. Now we need 2 numbers, multiplies to negative 12 and adds to positive, so would be a 1, positive 1x would be a positive 4 and a negative 3. Take a look at the bottom. Draw your 2 parentheses. We'll put our x terms in place. And now we need 2 numbers that multiply to 9 and add to negative 6, which will be a negative 3 and a negative 3. Now that we have it factored, we are ready to cancel. We can only cancel, since we have 4 binomials, has to be the same binomial on top as it is on bottom. Notice we only have an x minus 3 set, so we can cancel 1 x minus 3 from the top and 1 x minus 3 from the bottom. That leaves us with x plus 4 and x minus 3 as your final answer. If you have any questions about this topic, please contact your professor or stop by the Math Tutoring Lab or watch this video again.